Welcome to a slow, beginner-friendly lesson on what AWS Lambda is and why it fits Python so well, made for absolute beginners. The heart of the cloud section. Today we answer the central question of this cloud section. What is AWS Lambda, and why is it such a natural fit for Python? Lambda is Amazon's service for running code without managing any server. You write a Python function, you upload it, and Amazon runs it whenever something triggers it, a web request, a timer, a file upload. You pay only for the seconds your code actually runs. This lesson is a concept lesson. We do not deploy anything yet. We build the mental model you need before we write our first handler in the next lesson. Code without a server. Where are you? In the previous lesson, you installed the AWS CLI, ran AWS configure, and verified the connection with AWS STS get caller identity. Your laptop now reaches your AWS account. The next question is obvious: where do we actually run our Python code? The answer in this course is Lambda. Lambda is Amazon's serverless compute service. It runs your Python functions on demand, charges you by the millisecond, and removes the need to manage any server at all. Let us understand what that means. The connection is ready. We keep working in the same Cloud Foundations workspace. Over the next few lessons we add a file called hello_lambda.py inside the package. That is where our first Lambda handler will live. For today, you do not need to create it yet. Just know that the structure is ready. One project, one package, and we add handler files as we need them. Keeping all cloud work in one workspace makes it easy to test locally before deploying. A workspace ready for handlers. Move into the project and confirm Boto 3 is installed with UV add Boto 3. Boto 3 is the Python library we use later to invoke Lambda functions from a script. No new dependency is needed today, because this is a concept lesson. But it helps to know what is coming. Once we deploy a function, we call it from Python using boto3.client with the string lambda, then .invoke. That single line runs code living on an Amazon server. For now, just make sure Boto 3 is in your project. Boto 3 will invoke lambda. Here is the path ahead. Today is a concept lesson, so there is no run step. In the next lesson, we write the handler in hello_lambda.py. After that, we deploy it using the AWS CLI, AWS Lambda create function with several flags. Then we invoke it with AWS Lambda invoke, passing the function name and an output file. The commands look long, but each one has a clear purpose. We walk through them one at a time. Today, focus on the ideas. Today is ideas only. In the old world, you bought a server, kept it running day and night, and paid even when no one visited. That model wasted money and time. The old way wasted money. The word serverless sounds like there is no server, but that is not quite right. There is always a server. The point is that you never see it, never configure it, never patch it, never scale it. Amazon does all of that invisibly. You upload your code, and Amazon handles the hardware. When a request arrives, Amazon starts your code on a server, runs it, returns the result, and shuts the server down. You pay only for the milliseconds your code was actually running. Serverless removes the hardest part of cloud computing, server management, so you can focus on your Python. The hardware disappears. Every Lambda function in Python follows the same pattern, a function called lambda_handler that takes two parameters, event and context. Amazon calls this function for you whenever something triggers your Lambda. The event parameter is a dictionary with the input data. The function does its work and returns a dictionary, usually with a status code and a body. That is the whole shape. You already know how to write Python functions. Lambda just gives that function a specific name and a specific signature. A function you already know. Here is the Lambda model in a few steps. You write a Python function on your laptop. You package it and upload it to Amazon. Nothing happens yet, your code just sits there, costing nothing. Then something triggers it, a web request, a timer, another Amazon service. Amazon instantly provisions a server, loads your code, runs your handler, captures the return value, and sends it back as the result. When the call finishes, the server disappears. You are billed for the milliseconds between the trigger and the return. No idle time, no monthly fee, no server to maintain. Idle and free until triggered. Serverless means you never see the server. You hand AWS your code, and the hardware becomes invisible. Invisible hardware. The handler takes two parameters. The first, event, is a dictionary that carries the input data. If your Lambda is triggered by a web request, the event contains the request details. If it is triggered by a timer, the event contains timing information. The shape of the event depends on what triggered the function. The second parameter, context, is an object Amazon passes with runtime information, how much time is left, the function name, the request id. In practice, beginners almost always ignore context. It exists, but you rarely use it. Focus on event. Input in, metadata out. An event is just a Python dictionary. Here is a simple example, a dictionary with the keys name, age, and active. When your lambda is invoked, Amazon fills this dictionary with whatever the caller passed in. Inside your handler, you read values with the .get method, which lets you provide a default in case a key is missing. Name equals event.getName, world. If the caller did not send a name, you get the default world instead of a crash. This is the same dictionary skill you learned in the collections section, now applied to cloud input. A dictionary you can read. Your handler returns a dictionary. The convention for web-triggered lambdas is to return 3 keys. Status code is an integer, 200 means success, just like in HTTP. Headers is a dictionary of HTTP headers, like content type. Body is a string, usually a JSON string representing your actual response data. We go deeper on this in the next lesson when we write a real handler. For now, notice that the return value is a plain Python dictionary. Nothing new, just dictionaries, which you already know. A dictionary you can build. Every lambda is one Python function with a clear job: receive an event, do work, return an answer. One function, one job. Here is the complete life of a lambda function, step by step. You write the handler in a file on your laptop. You package it. For a simple function, that means zipping the file. You deploy it to Amazon with a single command that gives the function a name and an execution role. You invoke it, either from the CLI, from Python with Boto 3, or from a web trigger. You read the logs in CloudWatch to see what happened and debug errors. Finally, when the lesson is over, you clean up, delete the function, the role, the logs. Cleanup is how we avoid charges. Every lesson in this section follows this same arc. Right to cleanup, there is one more concept, the execution role. Every lambda function needs an IAM role attached to it. A role is a set of permissions. It answers the question, what is this function allowed to do? A basic role lets the function write its logs to CloudWatch. A more powerful role might let it read from a database or call another service. The role is how Amazon keeps functions safe. Even if your code has a bug, the function cannot exceed the permissions in its role. We create a basic logging role together in the deploy lesson. For now, just know the word role and that it controls permissions. Permissions as a badge. Think of the role as a badge. The badge lists what the function is allowed to do. A basic badge lets the function write logs, that is the minimum every lambda needs. If your function reads a file from S3, you add an S3 read permission. If it queries a database, you add a database permission. The security principle here is called least privilege: grant only the permissions the function needs, and nothing more. This way, even if an attacker triggers your function maliciously, the damage is limited to what the role allows. Grant only what is needed. Write the handler, package it, deploy it, invoke it, read the logs, then clean up. That is the entire life of a function. The full arc. Here is the pricing story, and it is good news for learners. The Lambda free tier gives you 1 million free invocations every month and 400,000 gigabyte seconds of compute time. A gigabyte second means 1 gigabyte of memory running for 1 second. So a function with 256 megabytes of memory can run for over 1.5 million seconds free each month. That is far more than any learner needs. The free tier renews every month and does not expire after 1 year. It is permanent for Lambda. You can learn and experiment without spending a cent. Permanent and generous. Let us do the math with a concrete example. Suppose your function uses 256 megabytes of memory and runs for 1 second. That is 0.25 gigabytes times 1 second, which equals 0.25 gigabyte seconds per invocation. Divide the 400,000 free gigabyte seconds by 0.25, and you get 1,600,000 free seconds per month, about 444 hours. You will never approach that in this course. The free tier is designed so that learners and small projects pay nothing. The math is on your side. When is Lambda the right choice? It shines for event-driven work, code that runs in response to something happening. A web request arrives, so run the function. A file is uploaded, so process it. A timer fires at midnight, so run a nightly cleanup. Lambda is perfect for short tasks that finish in seconds. If your workload is sporadic, sometimes busy, sometimes idle, Lambda is ideal because you pay nothing during the idle moments. Most beginner cloud projects fit this shape, which is why we start here. Short and event-driven. When is Lambda the wrong choice? First, Lambda has a hard limit of 15 minutes per invocation. If your task runs longer, Lambda cannot do it. Second, If you have constant heavy traffic 24 hours a day, a always-on server becomes cheaper than paying per invocation. Third, lambda is stateless, each invocation starts fresh, with no memory of the previous one. If you need persistent state, you need a database alongside lambda, not lambda alone. Knowing these limits now saves you from choosing the wrong tool later. Not long, not stateful. Lambda is brilliant for short, event-driven tasks. It is the wrong tool for long, heavy, stateful work. Knowing the difference matters. Right tool, right job. Quick self-check. Can you explain in one sentence what serverless means? Can you write the signature of a lambda handler from memory? Can you state the two parts of the lambda free tier? Can you name two situations where lambda is the wrong choice? If any feels shaky, rewatch the matching part. You do not need to deploy anything yet, that comes next. Today you needed the mental model, and now you have it. Say each out loud. Here is lambda in one breath. You write a Python function called lambda_handler that takes event and context. You upload it to Amazon. Amazon runs it whenever something triggers it, and you pay only for the milliseconds it runs. The free tier gives you 1 million invocations and 400,000 gigabyte seconds every month, more than enough for learning. Lambda is the right tool for short, event-driven tasks. It is the wrong tool for long-running or stateful work. That is the entire concept. Upload, trigger, pay per blink. Next lesson, we write our first real handler. We open the file lambda_function.py, define lambda_handler, and study the event parameter as our input. We build the return dictionary with a status code, a body, and headers. And we test the handler locally, by calling the function directly with a sample event, before we ever deploy it. Local testing is a habit that saves you time and money. The concept work is done. Now we write code. We write code next. If you want a quick practice, sketch the handler in a Python file. Define lambda_handler, read the name from the event with .get and a default of world, and return a dictionary with status code 200 and a body string. Do not deploy it yet. Test it locally by calling the function directly with a sample event dictionary. Print the result. You should see a dictionary with your greeting inside. When that works, you are ready for the next lesson, where we deploy it for real. Sketch it before deploying. Thanks for learning the Lambda model. Next we write our first Python handler and test it locally. The model is clear.